Hello, my name is Dr. Christopher Tay. I'm here to teach about agroecology as well as to talk about important subject which affects agriculture, which is climate change. I will discuss what is climate change and how it affects agriculture. So agroecology zone, we will talk about climate, the soil, the terrain, as well as the yields, crop yields. Now, there are many definitions to agroecological zones, but the basic idea is very simple. As defined by the Food Agriculture Organization, FAO, agroecological zone is simply classifying or dividing up an area based on its climate, the terrain or landform, the soil types, the land cover, how much vegetation there is, for instance, and the potentials and constraints for land use. So that this piece of land is then divided into many homogeneous units, so that each unit have similar properties. Each land area within this unit have similar properties to each other, whether it's based on climate, landform or soils, land cover, and potentials and constraints for land use. Now this is a mapping of the world area based on the climate. As you can see, the areas near the equator, they are red, including Malaysia, you can see. And as you go further up the equator, the color changes from yellow-orange, green to blue. And as you go further down, likewise, from red to yellow and green. And the red means it's hot, humid, wet. And as you go further up, it's cooler, and also certain areas are drier. So this is a very nice zoning, which shows that the further the equator is, it becomes cooler, and nearer the equator it becomes warmer. Some parts of Malaysia, for instance, here you can see it's red, that means it's tropical, and Africa as well, and Brazil and so on. And higher up, Europe, Central Asia is also green, which is about temperate, cool climates. As you go further up, it's very cold. The Arctic, Scandinavian countries, North America, and so on. This is based on agroecological zone based on climate. Based on soil. It's a rainbow of colors. You can see multiple colors. This goes to show that the world's soils is not uniform. Different areas have different soils. As you can see, it's not so clear like the weather, like the climate, where it's rainbow, it's a scattering of colors, as you can see. South America, you can see multiple of colors because they are made up of different types of soils. Malaysia, mostly yellow, which is basically, as you can see down, Malaysia generally has two groups of soils, the old soils, which is acrisols, ferrasols, and nitosols, and generally the younger soils, which are clay soils, candy soils, and potsols. Now this is based on terrain. Terrain means the legend that you see here. This is the how flat or how steep it is. The darker green means it's quite a flat land, level land. And as you go higher, yellow, orange, and red, they are very steep. As you can, so most of it is about green colors. This shows to show that a large area is quite flat, but there are other areas like Malaysia. It's not very clear here, but perhaps in your slide you will see that the color is basically in yellow. That means it's not flat and it's not very steep. Now, of course, the terrain will affect agriculture activities. The flatter it is, the easier to work the agriculture land. The steeper it is, erosion becomes a problem, and you have to have certain mitigation methods to prevent erosion and makes agriculture harder and more critical to environmental concerns. Some areas like Kazakhstan in the Central Asia, these are rather flat, as you can, because this whole country is on a steppe, which is very flat, and you can have large machineries going through the agriculture land. But Malaysia, large agricultural equipments like tractors is not practical because our land is just not as flat as other countries. This is based on land cover. The greener it is, that means the country is covered with lots of vegetations. Malaysia is quite vegetated. It's about 60% forested, but some areas are not, and Australia and so on. This is the crop growing land. We divide the land area of the world into different zones where it shows how long can we grow a crop. Malaysia, because it's in the tropics, it's purple, which means that as you can see the legend here, we can plant our crops all year round. Our crops have no difficulty growing anytime. But some countries no. You have only a specific period in a year, a duration of length, where you can grow your crops. In the winter, for instance, only certain crops can grow, or even you can't grow any crops in that period. So that part of the season in the year is not available for growing crops. But this is not true for Malaysia, where it's because of the climate, with a very stable and uniform climate, we can grow crops all year round. This is the land area for rain-fed soil suitability. Low inputs means the top title. The low inputs means it's based on subsistence. That means very little input that we use. Basically, either very little or no fertilizers we add. And you can see the area. Green means very good, yellow in the middle, and red means very bad for agriculture because of land soil suitability. Malaysia is in the middle, yellow. Compare this picture with this. This is rain-fed soil suitability with high inputs. This was low input, it's basically yellow, greenish yellows. But when you have high inputs, suddenly the whole land area becomes very green. That means that with high inputs, with high fertilizer, high labor management, you can make a soil which is not originally fertile, more fertile for agriculture purposes. So from yellow to green, so high input. High input usually means commercial farming style. This is rain-fed, just based on rain and soil suitability. Rain-fed means depending solely on rain, no irrigation for water. This is rain-fed and terrain suitability, low input. Limitation again because of you only depend on the rain for your water, and the terrain. Flat terrain makes agriculture easier, steep terrain makes agriculture more difficult. Low inputs mostly results in lots of yellow and greenish yellows, but if you have high inputs, if proper inputs, you can work a soil or an area into a productive area. As you can see, from yellow greenish to lots of greens, to shows that the importance of high inputs. This is the yield gap ratios. This shows that the legend, green means the ratio between the actual yield and the potential yield is 1 or very close to 1. That means the actual yield, what you're actually getting is almost the same as what the crop can give you. What you want is 1. That means you are achieving the maximum yield possible. So what you want is green, but as you can see, not many areas are green. Malaysia is light green, almost 1, but not really 1. But some areas like India, even the whole of country of India is an agriculture country, but the yield gap is yellow to red. That means it's not quite far away from 1, about here, about 0.2, 0.3. And some parts of North America, which is green, which is good. Central America, orange. South America, some parts are green but yellow. In Africa, the biggest continent, but it's red. That means there's a huge potential to increase the yield. They're only getting a very small potential of what they could get. Central Asia, orange-red. Europe, Western Europe, green. That means they are getting very high yields. They are meeting their potentials. Okay, desert. Before I go into climate change, I'd like to talk about desert. Desert, as you know, it's very little rain, less than 250 millimeters per year. The vegetation is very sparse, it's very dry, very hot, especially in the day, but ironically very cool at night because of lack of cloud cover to trap the heat. And agriculture in desert land is almost impossible, right? Without any help of irrigation. If you depend on rain, agriculture will not be able to survive. These show some examples of desert areas. You can see these pictures. The crops are very sparse, very few, and limited to shrubs. And you can see very little rain, very dry, so agriculture is very difficult in such an area. And now this is a very interesting picture. It shows a circle. This is right in the middle of a desert. As you can see, they're brown, very dry, and yet they are doing agriculture activities in this circle areas here. This is found in some places in the Middle East, like Libya. They do have agriculture activities right in the middle of the desert, and where they get their water from is from aquifers or groundwater. So they require water from groundwater to supply water in order to grow crops right in the middle. And this is an aerial photo. As you can see, they are very interesting, like buttons, because these are areas where farming is done. And as you can see, some areas are green, some areas are brown, like here. This means these brown areas that you see here, these are areas where the aquifers have dried up. So the land has stopped producing because water has run out. The only green areas that you see, these are the active areas which have still supply of water. So even desert farming, although water can be found, provided there is groundwater, it's not sustainable, in the meaning that it cannot continue forever. It's only for a short span. After a while, when water runs out, these green areas become brown and agriculture just stops.